Welcome to a video on writing a formula for a polynomial function where its graph is given. Consider example 4. Use the graph to write the formula in factored form for the polynomial of least possible degree. So we'll start with the leading term test. The leading term test tells us the end behavior on a graph of a polynomial function. Notice that our graph is pointing downward on both ends. So that means the degree of our function is an even degree, and the leading coefficient, let's just call it A, is a negative value. And now let's consider the x-intercepts, which will give us the zeros of the function. So we have 3 x-intercepts, one at -1, at +2, and at 4. For the first x-intercept, the graph touches that from below, and then it goes back down. And therefore, the multiplicity for this 0 is an even number. So we know x minus that 0 raised to an even power is a factor of that function. Let's make that even power the value 2. Now consider our next one at x equals 2. Notice that the graph here passes through the point 2, 0, but it flattens around that value. So x minus 2 is a factor of the function, but raised to an odd power. So an odd power, normally we would use the number 1 for that, but since it's flattened at this value here, the exponent on this factor is going to be larger than 1. So let's make that 3. And then for our last one, which is at 4, 0, notice that the graph here passes through and it's not flattened like the previous one. And therefore, x minus this number, x minus 4 that is raised to an odd power since, again, the graph passes through that point. But this odd exponent here, let's make that a 1, since it's not as flattened as the previous one. Hence, x minus 4 raised to the first power, along with the other factors, will make up part of the polynomial function. So we'll call this function p of x. And now we're missing the leading coefficient, which we know is a negative number. But let's go back to the degree here just to make sure we're on the right track. So we expand this out. Our first factor here is going to give us a second degree. Our next factor is going to give us a third degree. And then the last factor there is going to give us a first degree. So we multiply these x's together, we'll end up with x to the 6th power. And therefore, the degree of this function is even. So we're on the right track. And now to determine the value of a, we expect that number to be negative, but in order to solve for it, we need a solution point. So a good solution point to use is the y-intercept. So notice here on the graph of the function, 0, -4 is a y-intercept. We can substitute in those values as x and y to solve for a. So making our substitution for the output as -4 and our input as 0, we would end up with a times 0 plus 1 squared times 0 minus 2 to the 3rd, and then 0 minus 4, which is just -4, raised to the 1st. simplifying these numbers, we get a times, that's a 1 times -8 times -4. So we basically end up having the product of two negative numbers, which is positive now, 32, and then set it equal to -4. So we're dividing the equation by 32 to both sides. Our leading coefficient can be reduced as -1/8, and hence our polynomial function p of x is -1/8 times x plus 1 raised to the second times x minus 2 raised to the third, and then x minus 4 in factored form.